Hello everybody, I'm Kristo Männa and today I'll be giving you a little talk about multithreading in Unity. So, I'm not going to really explain multithreading, it's pretty self-explanatory, but I will give a little example of where you would use it. So I was making this thing called the Delta visualization project, and I had to simulate a lot of agents, like 2000 of them. And in this case what I did was I created a couple of separate threads, each of them simulated like 200 agents at a time, because it simply was not reasonable to simulate all of the 2000 agents on the main thread every thread. So yeah, so multi-threading can be very useful, but there are also very good reasons not to use it. I'll give an example of some of the problems that you will have with multi-threading. There are way more, but yeah. So the first one is context switching. This is to show that there are problems on the hardware level. Context switching happens when you have two threads, but only one CPU basically. And one CPU can only do can only execute one thread at a time. So what ends up happening is that it sometimes it does thread A, then it does a bit of thread B, then it does thread A again. So like switching it back and forth. But each of these switches is quite expensive. It's fine when this happens a little bit, but once it starts happening a lot of times when you have threads that have the same priority, you're going to have a bad time, especially when you have threads that basically fight with the main thread. The other thing is that creation of threads is quite expensive, and yeah, so you have to create your threads beforehand, and this just introduces a lot more complexity to your code. Also, it's a lot easier to make your program way slower using threading than if you did it not using threads. Alright, so this is an example of some problematic code. This is what we will want to avoid. In the start method we just call a thread method. This thread method does thread.sleep 3000. This makes the program just wait for 3 seconds. We use the sleep methods to simulate heavy code. So yeah, you don't want to do this because it will basically crash your game for 3 seconds. So Unity has these things called coroutines. They're not really threads, but they do solve a lot of the same problems that you can solve with threads, and they are way safer. So we have this thing called a coroutine method here. To make it a coroutine method, we have to say that it returns an I enumerator, and then inside of this we do this yield return new, and then we return something. In this case we return wait for seconds and pass in 3. What this makes this basically makes it so that when this coroutine is run, it will execute up to the yield, then it will wait 3 seconds, debug log this message, loop back around, wait for another 3 seconds, and so on and so on. Now how do we call this? We can start the coroutine using the start coroutine method. It's in the monobehavior namespace. We pass in a method to the coroutine, has to have the I enumerator here. You can pass in any arguments that you like, and we can also remember it. This method will return a coroutine. So in this case I'm remembering it, and then if you want to kill the coroutine outside of the method itself, you can do stop coroutine and pass in this routine. You can also just inside of here, not have an infinite loop, and once it reaches its end, it will automatically stop. Coroutine yields. We can have yield return new, wait for seconds, wait for fixed update. We can yield another start coroutine call. This will basically branch the main call off into another coroutine. It will complete that one, and once it's done, then it will come back to the main one. You can do yield 0 or basically anything else. If the Unity system doesn't recognize what you yield, then it will just wait until next frame. But 0 is commonly used. You can also do yield break. This just ends the coroutine. This is basically the same as a single return statement is for void methods. Then we have the enumerator. I put this here to explain a bit more about the coroutines. If you want to use the coroutines, you don't actually need to know what the enumerator does. The coroutines are really useful for timers, basically. But now the enumerator. The coroutine method is basically the same. Here we are returning a null. That's the only difference. And then in the start we create a new enumerator. We call this method, right? And we do dot get enumerator. This gives us an enumerator. And then in the update we can do enumerator dot move next. And what this does, it will execute this code until it hits a yield statement. In the first update it will execute this code until the yield statement. Then in the second update it will debug.log the message and repeat around back to the yield. And what happens is this is going to spam message from a coroutine each frame. Yeah, and the enumerator is also the magic that makes for each loops possible. But you can read more about it on the C# wiki. Then we have Unity Dots, the data-oriented technology stack. Inside of it we have the entity component system and the job system and the burst compiler. There's a lot more to it. Basically what it is that Unity wanted to completely rework their core and make it a lot faster. They do this by basically taking all of the data and putting it into one place. The trade-off with this is the thing that you get from using dots is that your code is going to be a lot faster, especially if you have a lot of separate entities, basically the agents that I showed before. The trade-off is that it is quite difficult to learn, and the code has to be, the minimal code has to be way more complex than normally. Dots will not be covered in this talk. Nowadays you can also go and learn dots. There was a period of time when there really weren't many materials about it. Now there are. If you want to, you can go and learn it. The C# thread. This is if you want to create your own threads. So how do you make it? Well, basically you use the thread class constructor. You pass in an action. In this case I just do an action to call this thread method. You can see you can have any arguments. Now in this thread method I do just a while true loop. Don't do this on the main thread. It will crash your Unity application. Really don't do this. Yeah, but using threads we can make it work. So we create this thread here, then we do thread.start. This will actually run it. And when you copy paste this code, or paste this code in your own Unity mono behavior and run it, you will see that it will spam message from a thread way faster than your frame rate is. That's because all that this thread does is spam this message. Yeah, this is how you create separate threads. So the C# thread, Unity API is not actually thread safe. So if you were to do something like debug.log transform.position, it will tell you that Unity API is not thread safe and not allow you to do it. The debug namespace is actually thread safe. So that's nice. You can use the debug on your separate threads. Simultaneous reading and simultaneous writing. When you read the same variable at the same time, everything's fine. When you write to it at the same time as another thread, it is not okay, because let's say you have a string when one and you have two threads writing to it. It's going to become a garble of both of the strings that the threads wrote to it, and just won't work. There are some types that you can write to at the same time. Those are int, float, bool, character. I believe there are a few others. Basically, these types are just so small that it only takes one CPU operation to write to them. For something like a string is pretty big. It takes multiple operations. There are like a lot of things that can go wrong, and the string is defined by like all of its bytes, basically. But in this case, one operation completely redefines these types, so they cannot become a garbled mess. Then also avoid zombie threads. Thread.is background should be set to true. Threads can be either foreground or background. Background threads die when its parent thread tries. Foreground threads don't. By default they're foreground threads. So to do that, you would between these two lines you would say thread.is background equals true. Also do set up exit conditions for threads. If you run this, you will notice that once you stop playing, this thing is still running. Yeah, because you didn't actually stop it. To stop it, easiest way is to create some kind of bool here, then implement another Unity method like the start one, like something like onDestroyed, and set that bool to true. And in this while loop, each time check if the bool is true. If it is, then just return, and this will safely exit from the thread. And then the garbage collector will come and clean it all up. Yeah. Okay. Counting with threads. As I said before, sometimes can be read and write to at the same time, int bool, etc. Int I can be write and read at the same time. What happens when multiple threads do I++? So I++ is actually multiple operations. So when you have two threads that do I++, the first one will read that the value of I is 0, and then the second one will also read that the value of I is 0. The first one will set I equal to 0 plus 1, so 1, but then the second one doesn't know that the first one already incremented I. All it knows is that I is 0, so it will set I equal to 0 plus 1, which is also 1, so two threads incremented I, but I is still 1, when it should be 2. To solve this problem, you should use the interlocked namespace classes, namespace methods. You have the increment one, which is the most useful one. You pass in a reference to an integer, and it is guaranteed to count it correctly on multiple threads. There's also decrement, add, and compare exchange. You can Google them if you're interested. Locking, signaling, and patterns. So now I'm gonna cover a bit of locking, a bit of monitors, a bit of the barrier pattern, going to go over the bulking pattern, and then I'll show how I usually set up my multi-threaded code. So first of all, locks. We have these things called lock. It's basically done the same way as an if statement. You write lock, put in some variable here, and then you can do something with that variable. Now the lock, when you lock the same variable and only access the variable inside of these locks, then you are guaranteed that this variable is only accessed by one thread at a time. So when two threads try to lock at the same time, the first one will get the lock. It will start doing something, but the second one will have to wait for the first one to release the lock. Once the first one is finished, release the lock, then the second one takes the lock and does something and also releases the lock. Now locks are pretty slow, and you shouldn't really use them if you can. But yeah, it is an easy solution a lot of the times to use a lock, but you really shouldn't, because it makes it very, very slow. Yeah, and the lock statement, it actually is synthetic stirrer. They are monitor statements behind the compiler just writes monitor stuff here. You can Google more about what the monitor is and where to use it. Basically, you can make more advanced locks. Okay, so these are locks. Now we have the bulking pattern. The bulking pattern is that we have a boolean of, let's say, work done. Actually, this should also have the volatile keyboard. I'll explain that in a bit. So in the thread method, we do thread.sleep to simulate a lot of work. Once that work is done, we set the work done to true before the work done is false. So in the update, when work done is false, we will say waiting for the work to be done. When it is done, then we will say all good. So here is an example how we can like monitor the state of the thread. And this should be set to volatile because okay. Basically, normally what you have, what happens is that the compiler assumes that all of your variables are accessed for one thread at that time. When multiple threads access them, it assumes that they're accessed by one thread at a time, so it can do some optimizations. These optimizations are false if it is not actually accessed by one thread at a time. You can get some weird behaviors. The compiler, if you add the volatile keyword here, the compiler will turn off those optimizations, and it will work more predictably, which is what you want in this case. Okay, then we have the barrier pattern. Yeah, so we have this auto reset event here. You can have a manual reset event as well. So you can think of this as a lighthouse. Basically, it can be turned on and off. We do this with the reset and the set methods. The reset turns it off and the set turns it on. When we do set, then the light is lit and all of the threads that are waiting on this lighthouse can pass through. Now the auto reset event, once you call set, it will only allow one thread through and others will still have to wait. Manual will allow as many as you want through. Yeah. So here we create a thread. In this thread, we again the while true loop, wait for the lighthouse to shine the light. Now here we have a context menu method. This little line here, this attribute makes it so that I can run it from Unity's like Unity by right-clicking on the mono behavior. Yeah, and then it will open the lighthouse, which will allow this to pass. So yeah, the barrier example is a barrier pattern is useful when you have say like 20 threads and you want them all to stop at one like place, like one barrier place. You collect them all there. Once they're all there, then from the main thread, for example, you can release them, and then they're gonna do their stuff and collect back at the wait event. That's one way to synchronize threads. Then we have the concurrent queue, which I find really useful. It's basically a normal queue, but it's thread safe, meaning you can use it from multiple threads at the same time. In the start method, we set up a thread method. In the thread method, we do some heavy code, and then we enqueue a action to the queue here. and then in update we take out all of the actions that are in the queue and we execute them. So let's say we have a game where we want to, when we have pictures and we are generating them at the runtime. Now each picture takes a lot of time to generate, so we put the generation code in another thread, like this sleep here, for example. Now once this is done, we want to display it. And to display it, we need to use the Unity API, so we need to run some code from the main thread, and this allows us to do it very easily. So we would do something like in this action, just set the paintings game object sprite to the new thing that we generated here. So we send this action to the main thread here, and then it will be run on the main thread. And this is a very simple way of synchronizing data between the main thread and worker threads. Then we have something called the thread pool. As I said before, creating new threads is very expensive. The solution is to use thread pools. A thread pool is basically just a collection of threads that you make at the start. You don't add them. Then you have tasks. You can send tasks to be done by the thread pool, and once they are done, they are completed tasks. So it's just basically a place where work gets done. Now thread pools are actually already implemented in the background if you're using Unity, and I believe other C# things as well. So we can just do threadpool.queue user work item, call in send in a thread method. Now this has to have this object state here because the thread method here has to follow a delegate pattern which has this object here. So we just have to have it here. And when in this thread method we can do thread.sleep like normally, and this code was run from another thread, and yeah, it makes it work. And finally, the most important threading thing is tasks. A task, well, it's they're really safe and they're really easy, and I think it's better if I just show you how they work. So a task, you create it the same way as a thread. Only difference is you write the task where you would write thread. You give them a method. So these tasks, they are automatically run on the background C# thread pool. So you don't even have to set it up. It just works. There are a lot of they have done a lot of the hard stuff for you. You really don't have to worry about anything when you're using tasks. If you take one thing from this little lecture, then it is that you should use tasks to do all of your threading in Unity, unless you have something really specific in mind. So use tasks. And that basically concludes my lecture. Thank you for listening, and peace out.